Hey everyone, today we will be looking at the Waldorf Micro Q. This is a wavetable based synthesizer, analog modeling synth that came out in the year 2000. So Waldorf has always been known for the wavetable synths. Their lineage goes way back to the PPG Wave, which was, one of the original, extremely popular even today wavetable synths. Also extremely expensive and rare for that matter. Just unbelievably cool machine. But after that, they went through a whole series of different synthesizers, specifically with the microwave range of synths, and then later the Q line of synths. And these were all wavetable-based synths. So the microwaves were much more expensive, extremely powerful synths. The Q came later, which was also very powerful. And then to have a lower cost version, they came out with the Micro Q, which was very similar to the Q, although there was some minor differences. Obviously, it's a 2U, rack unit. It's got very few surface controls. You're playing with buttons quite a bit, going through the different, menus here to adjust your sound. But it wasn't that, if you learn, it's not that big of a deal. There's also good third-party editors you can get for this to, to actually program it from a machine, from a computer, which makes it much easier to use. But that aside, this is still just a amazing sounding synth. So reviews on it, if you read them out there, they're mixed. A lot of people say they don't like it. I shouldn't say a lot. A minority of people say they don't like it for whatever reason. In terms of the Q, yes, it is cut down a little bit in terms of features, but it's still mostly all there, and it still has the classic Waldorf sound. So I love wavetable synths. I love the sounds that they're able to produce. Especially the Waldorf. I mean, this is just a very, very unique sound, unlike any other synth out there. In terms of all their synths that they have, just really, really cool machines. They are analog modeling, as I mentioned, so they're along the same lines as the Clavia Nord leads and the Roland JP8000. Everything's done in DSP. So your filters are primarily DSP based. All your sounds are DSP based. And because it's DSP based, the actual number of voices or polyphony you can have on this is based on the complexity of the sound. So as you eat up more and more DSP, your number of the amount of polyphony you have based on the number of voices will start to decrease. FM sounds are very CPU intensive on here, as is some of the filtering. So you just kind of have to keep that in mind. Now, by default, the Micro Q comes with 25 voices of polyphony. There is an upgrade, and actually it's a hardware upgrade you can get for this that'll increase that to 75. I do not have that in this, but from all my usage of it, 25 has been more than enough. So there are a couple common faults with this, primarily encoders, and mine it definitely has that issue there. So the design of the Micro Q is very solid. It's got some weight to it. It's a very heavy synth. It's not very deep, as you can see, only a couple inches deep. The back of it has got your main out along with two additional secondary outs as well. It's got an in. You can actually feed audio through this and filter it, which is pretty cool. Then your requisite MIDI, and then external 12-volt power supply. Because that power supply is external, one of your little wall transformers. It's one of the reasons why these can be made so small. They do a neat design on the top too, where it's just it's like a galvanized steel, whatever the case is made out of this, but they actually kind of print the logo and all the labeling on there, and I think it looks really cool. I'm sure it's a cost-saving measure as well, but it ends up looking pretty neat, I think. So mine has a couple issues which you need to address, and this is pretty common across the Micro Q line. These are pretty reliable synths. I mean, compared to some of the older synths I usually work on from the late 80s all the way through the 90s. This one's still relatively new in terms of the gear that I own, but the main problem you see is the encoders go bad. And that's how mine currently is right now. So I will need to replace those encoders. I will note that after the machine's been sitting for a while, that's usually when the encoders will start to get kind of funky. But if you just sit there and just cycle them and cycle them and cycle them over and over and over and over again, they will start to work. They'll come back, and then they'll be, honestly, after I do that for a while on this, they'll be perfectly fine. The problem with that is, though, too, is that, if I leave it off for a week or two and then go back to use it, I've got to do it again, which is annoying. Sometimes I've got to spin these things for a couple minutes to get them, up to speed where they're working. So they're extremely inexpensive to replace. I'm just going to replace them. You can clean them if you want. It's 20 years old at this point. I'm just going to replace them. Like I said, they're not expensive. They're a couple dollars a piece, and there's only 6 of them on there in terms of the actual, smooth rotary encoders. This is a rotary encoder as well, but it's actually, what do you call it, stepped. So you can actually, if you can hear it, it's got a different feel to it. So it actually is a different part than the rest, very similar, but they stepped that one there for a reason, which is usually for your sound selection and stuff like that. The second issue I have is some of the buttons on here. So a couple of these, you have to press them really hard to get them to work, and I'm not sure why. So like all these buttons over here work, no problem, but the couple right here, I mean, I've got to put significant force on them to get them to click. So I'm not sure what's going on there. The button may be bad, it might be something else. We'll have to open up, take a look behind the board there, which I'm going to do to get the potentiometers anyway. So not a big deal there to check that out. Other than that, everything else in this works. Like I mentioned, it's a pretty reliable machine, but we'll take it apart, take a look inside, kind of see how it's built, see what chips are using in there. We'll see what DAC they're using, kind of get an idea of the components that were put into this at the time. So let's go ahead and get it open. So just 6 screws total, top and bottom there. You'll note that they also don't have any screws on the connectors on the back here, which, when those are there, it gives you some strain relief onto the actual connectors. It prevents you if you jam a cable or trip over a cable, it doesn't break the connector off the board. They don't have any on here because they're pretty flush with the back of the case, but that makes it easier to assemble because the back cover just kind of slides right off, and then you're pretty much in. And as you can see, there's not a whole lot going on in here. So potentiometers, you can see them living across here, a couple back there as well. So you got to remove the main board here, and to get that, I'll have to remove the jack board off of the back here. Having some nice long bits like this make it a lot easier to get into tight spaces for some of these smaller screws. Pull all the knobs off the front. This little cable here is for the LCD. Uses just a standard 20 by 2 line LCD, so or 2 by 20, however you want to word it. I mentioned that sources for those LCDs in my first bench notes video there. The display you get for it doesn't have to be Waldorf specific. That this display has a standard HD 44780 interface. You can replace it with almost anything. And there is the main board. So here's your DSP section over here, a couple Motorola branded chips. We'll take a closer look at those a little bit later in the video. So here is the 2 buttons. They seem to be functioning fine now, which is odd. Alright, I figured out what's going on here. So let's see if I can get this shown. On the front plate here, it's actually 2 pieces of steel. So you've got this, whatever the steel is in the back plate, that's actually part of the chassis, and then you've got your front rack piece, and they're bolted together with a handful of little bolts here. But if you look here, trying to get this directly in line with the camera, you can see that the case isn't exactly lined up. Like looking this way at an angle, there's no yellow, but looking this way, you can see it on that side. And the reason is because these 2 pieces of metal have shifted side to side from each other. And what's happening is the buttons are actually getting jammed in there. So you can see it, button. It binds between those 2 pieces of plastic. Like I can stick that in there and it just sits there. Yet if I do it, you can't even get it out. If I put it here, it falls out much easier. So it slides between these 2 pretty easily. But these 2, it won't even go in. So it just kind of sits there, which explains why it was kind of stuck when I was removing it out. But all the other buttons are, they're oriented horizontal, or on a 45, including the power button over here. These are the only 2 that are vertical, which explains why these were the only 2 that were sticking. So what I'm going to do is loosen these bolts, slide this sheet metal back over, get them both lined up, and I should be fine at that point. Alright, so I've got it lined back up. See, there's yellow evenly kind of all around now, either way I look at it. I don't know if it's not really, I don't know if it's really showing up or not, but that resolved it. So the buttons, they definitely move nicely in those now. So that's all it was. In shipping, it probably just took a hit, you know, even though it was well packed, just enough to, you know, like I mentioned, it's pretty heavy. There's some weight to this thing, and that might have just shifted the sheet metal, causing us to bind. But that's all it was, which is good. Alright, so now on to the encoders. Like I mentioned, I've already ordered replacements, so I've got a whole set of them here for the 6 encoders right here across the front that are basically the smooth rotating encoders. And then I've got ordered just 2, just to have another spare. I got spares the other ones too for the actual encoder over here that is stepped. Now, I may not replace the stepped one because it's not bad. The shaft on it is cut too, if you can see that there. So you can tell that that's actually cut down. That's not a smooth surface there. So, and the replacement ones I purchased also, had a tall shaft. So obviously that was definitely cut down. So I'm just going to leave that one for now. I know it probably doesn't make sense because I'm in here and I might as well just replace it, but it's working fine. I don't have any issues with that one. So this is easy to take apart. It only took me a couple minutes. I can always replace it at a later date if I need to. I don't think this one wears as much, just because when you're editing sounds, you're primarily using these 4 over here. These are really the 4 that are not working on this specific synth. These 2 over here are also fine at the moment, but I'm going to replace them just because they don't feel as nice as the new ones. So the new encoders are made by Borens. I ordered them from Mouser. So for the smooth encoders, they are manufacturer part number PEC16 4020F and 0024. And then for the encoders that actually have the stepped encoders, they are part number PEC16 4220F and 0024. As of last week when I ordered these, the smooth stepped encoders were $1.18, and the actual normal stepped encoders were $1.28 each. So, very inexpensive parts. So with that, I will begin the replacement. Yeah, these original ones are made by Alps. Alps is a good brand. But so is Borens. I mean, they're both good brands. And you can see they are basically identical. In focus. Alright, so here's the first 4 encoders. I keep saying potentiometers, they're encoders. And which one was it? This one. So one of them was wobbly, as I mentioned, and this one is the one you can see why. These little tabs, focus, here are a little bit pulled away from the side of the encoder, and you can see a little gap there. Focus, focus. You see the gap there as a result. So that's why this one was so, loosey. But what you can do is, you can clamp these back down, kind of squeeze them back together, and that will, usually restore them. I mean, that's all it was that came apart. Granted, it's still dirty and worn. I'm going to replace it, but in cases where you've had that problem, or your encoders or even potentiometers, if you have the same design, get bumped by something and you feel that become loose, it's because that's what happened. You pulled it away from the case. So by taking the part, you don't even need to remove it. Just get the board out and get access to it, and you can crimp this back together, and that will usually resolve your issue in terms of that type of problem. But I am going to replace these now. There was a lot of solder on this board too, so it took me a little bit to get those out. And I will also mention that I'm not super thrilled by how clean this board is, just from Waldorf's manufacturing process. You can see a lot of clean flux residue and stuff like that on the board on the bottom, all the white kind of residue there. It kind of made a mess for when I was desoldering this stuff. So I'm actually going to clean all that residue up a little bit because I got a lot of flux in the board from pulling all that solder off with wick. So let me clean that first. Just going to use some isopropyl alcohol. So not trying to make this pristine, just get some of the flux residue off. I soldered the tabs on first, just the reinforcing tabs, just to make sure I got them all flat and lined up. And they all look good. So based on that, I'll continue to solder the pins. Okay, first 4 are in, so I got the remaining 2 to do. Alright, I've got all 6 replaced, so the 4 controllers over here, then the 2 over here as well. As I mentioned, I'm not going to replace the stepped encoder, strictly because the shaft is cut off on this one, and to replace it, I'd have to cut the shaft off which again isn't a big deal, but I just don't want to because this one actually still works, and there's no issues with it in operation, and I use this quite a bit, so I will leave it for now. If I need to replace in the future, I will. But just so you know that if you order that part number for this one, you will need to cut the shaft down, pretty short there to make it work with the factory knob. That completes the encoder replacement. So I kind of want to take a little bit closer look at the hardware here because it's amazingly simplistic for as powerful as this thing is. But there's some Motorola DSP on here, so we'll take a closer look at those chips and see what's making this thing run. Alright, so here's a little bit closer look at the DSP end and the basically everything that's driving this Micro Q by Waldorf. So the first chip we'll look at here is this Motorola chip. This is an MC68331. That is a 32-bit microcontroller. This guy will run at 20 megahertz. It's got tons of I/O, and it's based on the 6800 architecture, 68,000 architecture. So it's pretty common. You see it in a lot of different pieces of audio gear. I know a lot of the modern gear we've come across similar chips to that as well. So on this side of the board, we have our DSP. This is also by Motorola, and this is really what drives this entire unit. So this is the XCB56362. This is a 24-bit DSP engine, and it is used for all different sorts of applications. According to the datasheet, one of the most popular things for it is used for home theater receivers and things like that, for processing Dolby Digital, Dolby Pro Logic, different types of surround fields, and providing the additional reverb and stuff like that for those different sound fields. So tied to that, typically you've got your DRAM, which is pretty much a prerequisite for any DSP. And this guy can run up to 100 megahertz, so 100 MIPS performance out of it, which is pretty outstanding. So in this section we got some more RAM for the actual CPU itself, and then we have the obvious flash memory here. This would contain the OS, and most likely it would save your presets and stuff in there as well, because there is no battery on this unit that you would have to replace. So there is no battery-backed SRAM or any type of memory that would require a battery. Scooting the board over a little bit, right here we have our DAC, and that is made by AKM. So this is an AKM 4527. It's a pretty interesting chip. It is a combination DAC and ADC. So it's handling the analog digital conversion in from the jack that I mentioned earlier in the video for your audio feed through for your effects and things like that. And it's also handling, it's got 6 channels of digital analog conversion, 24-bit each channel. And the ADC is 24-bit as well. So it's a Delta Sigma style DAC like you find in a lot of modern gear. It does 64 times oversampling. You will find on the output there your requisite filters and stuff like that going through some of the op amps on the digital analog conversion side. But a really quality chip in terms of audio specs on that. And it's 24-bit as I mentioned, so I mean you've got 24-bit digital audio path basically through this entire device. One little chip I just noticed over here is this guy too, right there. So you got multiple clocks, I've noticed looking at the specs on this going through it. So you're going to have a clock for your microprocessor, you're going to have a clock for your DSP, you're going to have a separate clock for your DAC. You may have certain clocks for your DRAM, even though those are probably derived out of the actual CPU and DSP itself. So there's a lot of different clocks on here. And looking at the crystal, you've got a 14.31818 megahertz crystal, which doesn't really make much sense. So this chip right here is actually the clock driver for all the different clocks. So this is receiving, you can see it's right across the 2 pins there for the crystal, and it is a microclock MK1418. So what it's doing is it's taking that 14 megahertz and add some clock off that crystal there, and it's internally multiplying and scaling that clock for all the different sources you have. So everything on this has been driven by this clock chip there. You see this typically in all modern electronics because you run the same situation where you need multiple clocks to run all the different devices on there that have their own clocking requirements. Finally, looking over on the output side, you've got a handful of op amps over here. So these are probably just buffers for their actual audio outputs, and then also filtering for the outputs of your DAC as well. They'll be your low pass filters. So those are NE5532 op amps. So these are pretty high quality op amps on there. They're very low noise. They're designed for audio purposes, so they're spec'd well for this unit. I mean, all these components too, everything here is circa 2000, so you're talking almost 20 years old at this point. I mean, this DSP has been long obsolete, replaced by many new, more powerful devices, but still impressive design for how simplistic it is, for as powerful as this unit is, and it really shows the strengths of the analog modeling you can do with with DSP. Flipping the board over, you've got some basic power supply on there, regulation. This has got, I think I mentioned, it's just got a standard 12 volt DC input from a little wall transformer. It's nothing special. So it's a plus because it keeps the power supply out of the unit, keeps the heat down inside the unit. You don't have a transformer in here, a switching power supply. The downside of it is, again, it is an external transformer, which is kind of annoying. It's something that you can just gets in the way and you can lose and things like that. But so the point I'm trying to make is in here you do have some basic regulation. So you're going to have 5 volt most likely, probably 3.3 volt for some of your DSP. Probably nothing less than that. Around 2000, 3.3 was pretty much as low as those chips you would see. You don't see anything at 2.7 or down below, like that for this type of, at least this era of gear. So on the bottom side here you do have a handful of regulation. Got a couple devices here in TO220 packages, one over there, a big one on the heatsink here. These are probably 7805s. If I can look, yeah, that's 7805. That one's hidden by the little clip in the heatsink there, but this is probably your digital. It's probably your analog 5 volt. I don't know if these components and op amps require split rail. You see it in a lot of gear, on your older DACs and on your op amps where it'll need a plus and minus, 15 or 9 volt, rail to actually drive the op amps in the DAC there. But modern stuff typically a lot of times won't need that. I'd have to look. But one thing that bugs me here is kind of the design where they've got these, capacitors, electrolytics, basically touching, this regulator right here. And that's really just bad design. You want a little bit of breathing room between these caps and these hotter, these hotter components that get pretty warm. So again, I don't know how hot these get. They may not get that hot. This one probably at least warm enough to warrant this, fairly sizable heatsink there. But again, over here, you've got a device where the cap is basically just touching it. So I don't know. Just giving a little bit of space in there is usually always good practice. But in terms of capacitors themselves, it's kind of a mixed assortment here. A lot of them are Yageo branded caps, so I'm sure those are super high quality. And then you got some Philips caps in there as well. Everything's 85C rated. So again, just your basic, cheapo caps they put in here, nothing special. But the benefit of this too is I don't think this guy gets very hot. So this might get warm. I haven't had this on that long. When I have, I felt it. The case never really gets warm. So heat is the #1 killer for these before age. So because of the fact that they're 20 years old, as long as they're not hot, they're probably okay. As I mentioned, I've got no issues with this. There's no audio issues. There's no distortion, low volume, anything like that. And I've got no reason to replace these right now. And from everything I've read, these typically, at least on the Micro Q, have not been a problem. Another 10 years ago, things will change. We'll be 30 years old at that point. You might start seeing these, start to fail and leak and be problematic for other reasons. But so I'm going to leave them for now. Again, this is super easy to take apart. If there ever is a reason, you can get back in there and replace them, for a future date. But one last thing, just a quick look at the jack board here. You got some circuitry over here for your MIDI, opto isolator for isolation between MIDI and a little 7808 regulator there. So something this board needs 8 volts, possibly some of the stuff for the MIDI there. But besides that, not a whole lot. So these jacks ever go bad too, they're extremely easy to replace. You can just remove this board and swap them out really quick, which is nice. I'm going to get the unit reassembled now. While you have it disassembled, it's a really good opportunity to clean it. You can really get in there and clean the face good, because you don't have to worry about, you know, getting around buttons and your shafts, your potentiometers, or your encoders and things like that. So always clean, you know, your gear when you have it open. It's a perfect opportunity to do so and get all that dirt, you know, off that's hard to get normally. Alright, so I have the Micro Q reassembled, cleaned up, put back in the rack. It'll be easier to test it over here because I actually have a pair of studio monitors at this spot versus just on my bench with the crappy speakers that I normally use. So this will hopefully allow you to at least hear it a little bit better instead of the crappy sound I typically have. So we will power it up and it will come on and go through its little power up sequence on the display there. It'll just take a few seconds. Firmware 2.22. So this is actually the latest firmware for the Micro Q. There is a 2.23 version, but if you have the Waldorf Micro Q, you don't need it. The 2.23 version was for the Micro Q Lite, which came out later. And that was basically an identical piece of hardware to the Micro Q, except for the firmware on it was software limited. That is, it didn't have as many voices or polyphony, possibly some other features, I'm not entirely sure, as the regular Micro Q. And you could buy a license to unlock that, basically. And that 2.23 version of the firmware supposedly is what basically allows your Micro Q to become, or the Micro Q Lite to become a full Micro Q. So, anyway, we will check all the encoders to make sure everything works. So, scrolling here, so I've got no issues with that, but again, it worked fine before, so it wasn't a problem. This is your master volume. Works 0 to 127, no issues. This selection here, same thing. Two different sounds through your different banks, no issues. So go through. So I'm on oscillator 1, not shifted. So the 4 knobs here will be your octave, detune, shape, and PWM for this first oscillator. So going through, we can see that the octaves change correctly, and they feel fine. It feels fine too. There's no bumpiness or anything. These potentiometers, or these I keep saying potentiometers. These encoders feel really nice. Detune works great. Negative 64 up to 63. Shape. So these are going through your different actual shapes for that oscillator. No issues. PWM. Again, negative 64, 63. Feels good. No problems. So we're good there. I'm assuming, again, all these buttons work fine now, so no stickiness there, which is really nice too. And everything else worked before, so it wasn't a problem there. So there we go. That's how you replace encoders on the Micro Q. It's super simple to do. It comes apart really easily. Alright, we'll just go through a couple sounds on here, just to see what it sounds like. I mean, this is just, I love this synth. It is just a great sounding synth. So these sounds I'm going through are just some presets on the Micro Q that were there that I like a lot. They really emphasize or show the sounds this unit can make based on the wavetable synthesis that it can do. Some of these sounds are very PPG-like. So that is it. This is the Waldorf Micro Q encoder replacement, and just kind of an overall look at it. Very cool synth. So I hope this video was beneficial to you, and thank you for watching.